This is Chapter 2, Summarizing Data in Tables and Graphs. For this chapter, you will probably want a ruler or some sort of straight edge. We are going to be doing some graphing, and so you might want some sort of straight edge to help you out. You're also going to want your calculator from now on. You don't need it for Chapter 1, but you do for the rest of the course. You need a TI-83 or a TI-84. It doesn't have to be the plus silver edition, just any TI-84 will do. 84 is better than 83, but if you already have a TI-83, that's fine. This is not optional. You need this calculator. There are things in this course that can only be done with this type of calculator. Not a TI-86, not a TI-89, no other calculator. It has to be a TI-84 or a TI-83. So this is not an optional piece of material for the course. This is a required piece of technology. We're not going to be using Microsoft Excel for the course. If you already know Microsoft Excel and you would like to use it, that's fine. But I'm going to be teaching all calculations using the graphing calculator, not StatCrunch, not Microsoft Excel, but everything in the calculator. Alright, so for Chapter 2, Section 2.1 is about organizing qualitative data. So let's remember what qualitative data is from Chapter 1. That is the categorical data. So when we have different categories, we're going to learn different displays for categorical data. The first thing we need to know how to make is what we call a frequency distribution. A frequency distribution lists each category and the number of occurrences for each. So the number of occurrences is called the frequency. How frequent does that category come up? And how many for each category. So for this problem, a physical therapist wants to determine the types of rehabilitation required by her patients. To do so, she obtains a simple random sample of 30 of her patients and records the body part requiring the rehabilitation. So that's what Table 1 is. Construct a frequency distribution of the location of injury. So you can see her raw data, all the different 30 patients and where their rehab was. I've made a list of the body parts in alphabetical order. For categorical data, you can put the categories in any order you want. I just went alphabetical to make it easier. Your textbook does not go alphabetical, but that's okay. It does not matter what order we go in. And so what I want you to do is count up how many injuries or rehab were for the back, how many for the elbow, groin, hand, etc. How many of each injury. When you add up all your frequencies, your total should be 30 because the sample size is 30. So pause the video, count up how many of each one, write a number here. All of those numbers should total to 30. Alright, you should have gotten 12 back injuries, 1 elbow, 1 groin, 2 hand, 2 hip, 5 knee, 1 neck, 4 shoulder, and 2 wrist. If you add all those values up, all the frequencies up, you get to 30, which is your sample size. So that's called a frequency distribution. It's just a table organizing your categories and their corresponding frequencies. Now we're going to talk about relative frequency. For relative frequency, you're going to divide the frequency by the total sample size. Relative frequency, you divide the total number of entries. Divide the frequency by the total number of entries, the total sample size. So for relative frequency, you're going to take the 12 and divide by 30, and that gives you the decimal 0.4. For precision, we use 4 decimal places, even if that means we add zeros. because in statistics we have to be very precise with our values. So for the next one, it's going to be 1 divided by 30, and you can just divide in your calculator. 1 divided by 30. If you get a repeating decimal, you want to round to 4 decimal places. And you want to round properly. Remember your rounding rules. If it's 4 below, round down. If it's 5 or more, round up. And you want to have 4 places after the decimal point. We have 1 out of 30 again. So 0.0333 again. 2 out of 30. When you divide this, you get 0.6 repeating. Notice the last one is a 7, and that's because the 6s continue and they rounded the last 6 to a 7 because your calculator only has that many spots for memory. We're going to do the same thing, but we only want 4 decimal places, so that last decimal place is going to be rounded to a 7 because 6 rounds up. Then again, we get 2 out of 30. Then we have 5 out of 30. Again, we'll round that to 0.1667. Then we have 1 out of 30. So this is a pretty easy task. It's just dividing. 4 out of 30. 0.1333. And 2 out of 30 again. 0.0667. If you add up all the relative frequencies, if you add all these up, you should get pretty close to 1.0, which represents 100% of the data. All of these values are percentages. So relative frequency is like a probability or a percentage of occurring. So 40%, 3%, 7%, etc. So all of these are percentages. So for precision, we use 4 decimal places. When we're summarizing or graphing or generalizing our results, we can round off to 2 decimal places. So that would be 0.40, 0.03. The squiggly equal sign means approximately equal to. That means you're rounding. So this is 0.03, 0.07, 0.07, 0.17, 0.03. So you can round off to 2 decimal places when we're generalizing, but on your homework it's going to want 4 decimal places. Alright, so with all this information, with our body parts, our frequencies, and our relatives frequencies, we're going to make something called a bar graph. And you might have done this a long time ago in your education. So it might sound kind of familiar. We're going to specifically talk about how a bar graph works and where we put everything. So for a bar graph, you have categories on one axis. And you can do horizontal or vertical. We tend to do horizontal for the categories. And then we have frequency or relative frequency on the other. So categories along one, frequency or relative frequency along the other. The rectangles that we're going to draw are going to be of equal width, and we're going to have a space between each rectangle. So what we're going to do is, for the first graph, we're going to put the B for back. So I've abbreviated each one of these with a letter or 2 to make them easier to refer to. B for back is going to go between the first and second mark. So between the corner and the first mark, we're going to put the letter B for back. Then we're going to skip a space, and we're going to put E for elbow between the second and third mark. We're going to skip a space. We're going to put G for groin, skip a space, and we're going to keep skipping a space between each body part. Knee, neck, shoulder, and wrist. So you might want to make a note that we skip a space between each category. Bar graphs have to have those spaces, and each bar is going to be of equal width. So So we have the body part along the x-axis, along the horizontal. You always want to label specific to the problem. So whatever these categories are, you want to label what they are. Are they the body part? What are they? So be specific to the problem. Along the vertical, we're going to do frequency. And then on the second graph, we're going to do the same thing with relative frequency. So for frequency, we're just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is usually scaled for you, especially because the homework's digital. So you'll just count up, and you're going to put a bar that goes all the way up to 12 for back. This is where you might want your ruler. You're going to make your bar exactly the width for back. And if you want to, you can kind of fill it in or color it in or shade it in if you have a pencil. That's your bar for back. Then you're going to skip a space. Elbow only had 1. So we'll make a small bar for elbow. Groin only had 1. Hand had 2, so we'll go up to the second mark for frequency. Etc. and so forth. Make sure to put a space between each bar. Knee goes all the way up to 5. Three, 4, 5. There we go. Neck is 1. If there was a category with 0, we would still put a bar with nothing. So we don't skip anything on this. We don't leave any categories out, even if their frequency is 0. We keep it nice and scaled and even as we go along. Nice, pretty bar graph. Microsoft Excel can do these, but again, we're not using Excel for this class. I want you to be able to understand how to create these by hand. Labels are very, very important. You want to title your graph, you want to label your graph so you know if you're looking at frequency or relative frequency, and you know what the categories are talking about. So we're going to make the same bar graph, but instead of using frequency, now we're going to use these rounded off relative frequencies. So categories are going to go in the same order, skipping a space in between each one. Again, we're going to label the axis as body part. On your homework, pay very careful attention to the labels because they'll switch them around just to test you to make sure you're paying attention. So watch those labels. Now we're going to kind of eyeball the relative frequency. It's a little harder. You'll just kind of have to do your best of how tall the bars should be. So just kind of approximate. 0.40 is a little easier, but 0.03, you'll just kind of have to estimate about where that is. So relative frequency by hand is not always the most precise, but it at least gives you a comparison between the different categories. Hip was also 0.07. So now I'm looking at these blue numbers here to determine the height of my bars. So knee is 0.17, which is just below 0.20. And everything's relative to each other. So the bar graphs are going to look very similar. It's just one's using frequency and one's using relative frequency. Shoulder is 0.13. Somewhere in there. Wrist is 0.07. So you're kind of eyeballing where these guys go. I think it's a little taller there. Your homework, it'll be a little more clear. Some of the homework problems have a little magnifying glass with a little plus sign. If you click on that, you can see it a little bit better. Or you can zoom in on your screen so you can really see the different values. But there's just different homework questions reading bar graphs with frequency and relative frequency. So it should be pretty easy. And there's more examples in your textbook. I just chose this one to kind of work by hand. All right, so those are bar graphs for qualitative data. Your textbook talks about pie charts and side-by-side bar graphs and lots of other ways to display categorical data. Bar graph's the only one I'm worried about. Pie charts and some of the other ones we just don't do in this class. So we're going to go ahead and move on to section 2.2 on organizing quantitative data. This is where we're going to spend the majority of our time in chapter 2 on quantitative data. Remember, quantitative data is your numerical data. And there are two different types. There's discrete and continuous. We're going to talk about discrete first, and then we'll get into continuous second. Starting with discrete data. So the frequency table looks very similar to how it did for the categories. Instead of categories down the side, we have our different outputs. So these are all the values from the raw data that we could possibly have. This data is referring to how many customers are arriving at a Wendy's fast food restaurant between certain hours. So 7 arrivals, 6 arrivals, 6 arrivals, but within a certain time frame. So this is what we call the raw data. And so they looked through this and saw that the smallest number was 1 and that the biggest number was 11. So from there, we include every discrete value in between, 1, 2, 3, 4, all the way to 11. Notice that there was never a time with 10, but we still include it in our distribution. So once we find the smallest and the biggest, every option in between must be included to keep everything evenly spaced. Your textbook talks about tally marks. I've learned that not all students understand tally marks, so if that's not your thing, don't worry about it. We're just counting up how many times did 1 occur, how many times did 2 occur, how many times did 3 occur. So they've already counted up the frequency of each number of arrivals, and they've already calculated our relative frequency for us. So histograms are similar to bar charts, but without the spaces. So it's similar to a bar chart, but no spaces. We talked about for a bar chart, the categories can go in any order. For a histogram, it has to go, I don't know if that's called ascending or descending. It has to go least to greatest. Not the frequency, but the actual outputs, the actual values. So with categorical data, it can go in any order. I said it went alphabetical, but that part doesn't really matter. For numerical data, for quantitative data, it has to go least to greatest, all of your outcomes. So we are going to title this Arrival at Wendy's. We are going to use relative frequency here. And we're going to make what's called a discrete histogram. Now a discrete histogram, the bars are centered over their values. Very similar to the categories. So if you go back to page 1, the bars were over each categorical letter. Same idea here. So we're going to put 1 between these two marks, 2, 3, 4, 5. We're not going to skip any numbers. 9 and 10, 11. You can put 12 even though we didn't have 12 as an output. So notice the number 1 is between these two marks. The number 2 is between those two marks. I know it's kind of hard to see. So when we do continuous histograms, that'll be different. But for discrete histograms, each bar is centered over their values. So for 1, the relative frequency was 0.025, which is just barely above the axis. For 2, the relative frequency was 0.15. Again, you can use your ruler to kind of help you out. The bars touch, so there's no spaces. And they're centered over their values. So for 3, we have 0.025 again, very small bar. For 4, we have 0.1. For 5, we have 0.175, which is up there. And they just stack all against each other. For 6, 0.275. Use that ruler. So all smushed together here. For 7, we had 0.125. About there. For 8, 0.05. For 9, we had 0.05 as well. For 10, we had 0, so we're just going to kind of draw a flat line there to show that space. And for 11, we had 0.025. So very similar to a bar chart, but you squish all your bars together and each output is directly under its bars. Alright, I'm going to pause there because I don't want the video to cut me off. So this is a discrete histogram, and the next one we're going to look at is a continuous histogram.